Now let us talk about holography. This is a theory developed in 1947 by a scientist named Dennis Gabor, which is a result of winning the Nobel Prize in 1971. So hologram comes from a Greek word holos, which means whole, and a gramma means writing. So let us know more about holography. Holography is a process or technique of making three-dimensional image of the object. A hologram is produced by the interaction of two beams of laser light. One is the object beam coming through the object, and another is a reference beam coming directly from the source. In the principle of holography, we have during the recording process the object wave or the wave illuminating the object and the reference wave which comes directly from the source interfere in the plane of recording medium and produce interferences fringes, and this photographic plane carrying the interference pattern is what we call hologram. The interference fringes contains all the information about the intensity and the phase of scattered beam from the object. In the reconstruction process, the hologram acts as the diffraction grating. This is eliminated by the wave called the reconstruction wave, wherein in most cases dissimilar to the reference wave used for recording the hologram, and the image of the object is reconstructed from the hologram. So, in cases of which holography inverses to photography, photography is the 2D record of a 3D object, whereas holography gives a three-dimensional form of original object. Hologram is a positive pattern, whereas in conventional photography, negative pattern is produced. In ordinary photography, each region contains separate and individual part of the original object. The destruction of a portion of a negative leads to a irreparable loss of information corresponding to the destroyed part. On the other hand, each part of a hologram contains information about the entire object. Destruction of a point of a hologram does not cause a loss of information about the object. Each separate fragment is capable of producing image with a reduced clarity. So the application of holography is as the following. We have the holographic interferometry, holographic microscopes and radars, supermarket scanners, optical computers, holographic television, improved design of aircraft wings and turbine blades, holographic lens in aircraft head-up display, data storage, art, and lastly, medical applications or biomedicine. So the construction of hologram is as follows. We need a laser light which is highly coherent and monochromatic light, lenses, mirror, photographic film, and an object. We also need a beam splitter separating the laser light into two beams, which are the reference beam and the object beam. Also, the reference beam aimed at a piece of holographic film by the mirrors, while the object beam directed at the object to be recorded to illuminate object and then meets the reference beam at film. Then it produces interference pattern of object beam and reference beam which is recorded. The film is developed and this is what we call the hologram. This hologram contains all the information about the intensity and the phases of the scattered waves from the object. I have here my own example of a hologram.